In the previous video, we had discussed the 6 relational operators provided by Python with suitable examples. Logical operators can be used to combine multiple relational expressions and yield a final Boolean output. The three logical operators provided by Python are shown on your screen. Let's discuss each one of them. The first one is the logical AND operator, and in order to illustrate it, we can see that we have two variables, var1 and var2, initialized with values 5 and 7 respectively. Now we are combining two relational expressions. The first relational expression is comparing or is checking whether var1 is less than var2. The second relational expression is checking whether var1 is equal to var2. Now, since we want to combine the two relational expressions, we are using a logical operator. In this case, we are using the logical AND. Now, logical AND evaluates the relational expressions such that only if the first relational expression comes out to be true does it move on to the second relational expression. Here we find that var1, which is 5, is less than var2, which is 7. As a result, the first relational expression is evaluated to be true. Now, since the first relational expression comes out to be true, it moves on to evaluate the second relational expression. Now, we can see that var1, which is equal to 5, is not equal to var2, which is equal to 7. As a result, the second relational expression, which I have currently highlighted, evaluates to false. The logical AND expects all relational expressions. In this case, there are two relational expressions. Logical AND will expect all relational expressions attached to it to yield true output if the final expression has to be true. In this case, the first relational expression, var1 less than var2, comes out to be true, but the second one comes out to be false. As a result, the overall result of the expression comes out to be false. In the second example, we have the same values for var1 and var2. Now we are checking whether var1 is greater than var2. We can see that var1, which is equal to 5, is lesser than var2, which is equal to 7. As a result, the first condition, var1 greater than var2, evaluates to be false. When logical AND finds the first expression to be false, it will not check the remaining expression. In fact, at any point, if it finds an expression to be false, it will not check the remaining expressions from there onwards. Now, since it finds var1 greater than var2 condition to come out to be false, it will not check the remaining conditions. As a result, what we get is false. Since the first expression comes out to be false, the entire expression comes out to be false. So logical AND will yield a true output only if all relational expressions attached to it come out to be true. Now, in the next example, again, we have the same values. We have only changed the conditional expressions. In the first case, we have lesser than or equal to. Obviously, var1 is lesser than var2. So the first relational expression comes out to be true. And var1, which is equal to 5, is indeed not equal to var2, which is equal to 7. So in this case, the second relational expression also comes out to be 2. We can have any number of relational expressions. In this case, we have 2. We can have 3, 4. We can have n number of relational expressions. Here we find that both relational expressions are coming out to be true. Both relational expressions are giving true values. As a result, the logical AND will give us a true value. Now, the next logical operator that I would like to introduce is not. So what not does is it simply inverts the output. So if you observe the part that I have currently highlighted, I've simply taken that part and copied it in this portion, which I have now highlighted. And what I'm doing now is I'm simply taking the not value. So it came out to be true, right? We just now saw that it came out to be true. So if we take the not of true, we'll get false. So not will simply act as an inverter. A true value will become false and a false value will become true. Again, we are dealing only with Boolean values here. Okay, so that takes care of logical not. Next is logical or. Logical or will yield a true output if any one of the conditions come out to be true. Otherwise, it will yield a false output. Logical or will yield false only if all conditions only if all conditions attached to it come out to be false. In this case, we find that var1 is not equal to var2. So the first condition is not satisfied. However, the second condition is satisfied. As a result, it comes out to be true. So we can see that the output in this case is true. Same thing happens in the next example where var1 is indeed less than var2. So once it finds a true condition, it ignores the remaining conditions. So it will ignore the next condition, which is var1 equal to var2. It will simply find that the first condition, var1 is less than var2, comes out to be true, and it will print a true output. Now, in the next example, what we find is var1 is not greater than var2. So the first condition comes out to be false. It goes on to check the next condition. Once again, var1 is not equal to var2. So var1 is not greater than var2. Var1 is not equal to var2. So both conditions come out to be false. As a result, the overall expression is false. And in the final example, what we do is, again, we apply the not operator just for demonstration. So if we take the invert of false, we get true. So in this case, we got the value as true. So you can find that what I did was I took the previous example's expression and simply pasted it here in my next cell. I pasted it here in the next cell and I took its not value. So if the previous value came out to be false, and if I take its not, what I get is true. So that's how logical OR operator works. It expects all operands, or it expects all expressions attached to it to be true. In fact, it expects, I'm really sorry, it expects at least one of the expressions attached to it to be true. If all the expressions come out to be false, if all the expressions attached to logical OR come out to be false, only then the result is false. If at least one expression attached to logical OR come out to be true, then the overall result is true. And the remaining conditions, the point where you get a true expression, from there onwards, the remaining expressions are completely ignored. If you found this video useful, do like it and subscribe to our channel. If you have any doubts, please feel free to leave them in the comment section below. I hope you found this video useful, and I'll see you in the next one. Thank you.